let's look at some common angles that will be helpful to memorize their trig functions, at least for sine and cosine. Because once you have sine and cosine, you can essentially figure out any other angle. So the angles we're going to look at are 30 degrees, 45 degrees, and 60 degrees. And remember, 30 degrees is going to be 1/6 of 1. Remember, 180 is pi, so we're looking at pi over 6. 45 is essentially 1/2 of 90, and if we know that 90 is pi over 2, that means 45 is pi over 4. And then 60 degrees is going to be twice of 30 degrees, which would be 2 pi over 6, which would simplify to pi over 3. So here are our three common angles. And remember, we'll talk about this in a second, but a lot of your reference angles all the way around the axes will reference these as well. So first, let's look at sine of the angle. So sine of pi over 6, or sine of 30 degrees, is going to be 1/2, and cosine is going to be the square root of 3 over 2. If you were to make points on your axes with a terminal side at 30 degrees, these are the ratios that you would find. Now, 45 degrees is a little easier to remember because the sine and cosine are identical. They're both square root of 2 over 2. Finally, with 60 degrees, the sine is just the reverse of the 30, so your sine is radical 3 over 2, and your cosine is 1/2. Now, that's really all you would need to essentially memorize, because tangent of theta is simply sine theta over cosine theta. So if I were to take 1/2 over the square root of 3 over 2, I can then cancel out my 2's. I get 1 over the square root of 3. If I were to rationalize that, I would get square root of 3 over 3. For 45, sine over cosine, they're identical. So if you divide those two, you would essentially get 1. And for 60 degrees, now we have square root of 3 halves over 1/2, where my 2's cancel out. So I have square root of 3 over 1, which would simply be the square root of 3. So there's the sine, cosine, and tangent of those common angles. Now let's remember that sometimes we're going to be using those as reference angles. So it would be helpful to know what sign each trig value would hold in each quadrant for when I'm using a reference angle. So we know that sine, cosine, and tangent in the first quadrant, they're all going to be positive. Those are the angles we just defined. However, when we come over to the second quadrant, now my x value is going to be negative. That's going to make my adjacent side negative also, which is going to affect the cosine. Sine is still above, my opposite side is still above the x-axis, so sine is still positive, but now cosine is going to be negative, which is also going to affect my tangent and make it negative. In the third quadrant, sine is now dipping below the y or the x-axis, so my y value is going to be negative. My opposite side would be negative. Cosine would also be negative, so tangent, which is sine over cosine, is going to be positive, And then in my fourth quadrant, sine is still negative, but now cosine is on the right side, so it becomes positive, and tangent becomes negative. So let's see if we can use this information to find the exact value of sine of 4 pi over 3. If I were to sketch that angle out, if you divide this is your pi over here. If you divide your pi up into thirds, it might look something like this, where you have 1/3, 2/3, 3/3. I should have drawn my angles a little bit higher, but what I'm trying to say is this section, and this section each make up 1/3 of pi. So 4/3 of pi would come down here. 1, 2, 3, 4. So now we can use what we discussed earlier. If we get rid of this pi here, this reference angle is going to be pi over 3. So now we can use what we discussed earlier. If we have pi over 3, that's our 60 degrees. The sine is going to be square root of 3 over 2. And you can, if you want to think of that in terms of degrees, you essentially have 180 degrees divided in 3. So this is 60, 60, 60, and then you have one more 60 for our reference angle. So now we found the value. Now we need to just find the sine. And since we're down here in the third quadrant, notice the sine is negative, both the sine of the sine. So my answer is going to be negative square root of 3 over 2. We'll look at another one here. Now we want to find the exact value of the tangent of 150 degrees. That's going to be 30 degrees away from 180. So when we draw this here, our reference angle is going to be 30 to make this angle from the start be 150. So we do know the tangent of 30 degrees from our chart earlier. It is going to be square root of 3 over 3. And now our sine of tangent, notice when we're in the second quadrant, the sine of tangent is negative. So all we have to do is make the tangent of 150 be negative square root of 3 over 3. So now we're looking at finding the exact value for secant of 15 pi over 4. And of course, pi over 4 is what splits the axes in half. So if you can imagine counting 15 of these half axes, essentially, you've got 1 pi over 4, 2 pi over 4, 3, 4 pi over 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Pi over 4 is going to lie down here. So I'm going to be using, of course, pi over 4 as my reference angle. And remember, secant theta is the same as 1 over cosine of theta. And we know that cosine of pi over 4 is always going to be square root of 2 over 2. So we've essentially got 2 over the square root of 2. If we rationalize that, not what I wanted to do. I wanted to cross out the square roots there and make this 2 square roots of 2. When we get rid of the radicals, we have 2. So then those will cross out and we get the square root of 2. And now, remembering that our sine of cosine is going to be positive in the fourth quadrant, so that would also make my secant positive. So we'll just leave that at square root of 2. Now, I know you probably didn't have a whole lot of time to memorize the chart, so reference it if you need to. But see if you can find the value of the cosine of 4 pi over 3.